doing well. Today we're going to do a little mini lesson on solving systems by substitution. So let me go ahead and start that. So your essential question is how can you determine if and where two lines cross? And the learning target is I can determine the solution to a system equation using the substitution method. All right, this slide is simply the procedure. If you'd like to write it down, feel free. Go ahead and pause here and jot it down. You can use it later or you can reference this video again as needed. All right, so I'm going to go through the procedure in a slightly different way. I'm just going to do it step by step for one example problem. So our goal is to determine where two lines cross. That's what a system equation is, and this technique is called substitution. The first step is to solve one of the linear equations for a variable to isolate the x or y if necessary. Oftentimes when you're doing substitution, you already have a variable isolated, so you can skip this step. First thing I like to do when I'm figuring out which one I'm going to isolate is just look at the equations. The equation on the left here, I already have a y that does not have a coefficient or a coefficient of 1, which means all I have to do is move that 2x over. On this one, both my x and my y have a coefficient of something other than 1, which means an additional step is going to be needed. So I'm going to go ahead and isolate the y in this equation right here. All right, so let me rewrite it down here. So it's pretty straightforward. You guys have done this before in different ways. So I have y equals 2x, x, not a dash, 2x equals 5. Okay, so all I'm doing is subtracting the 2x on both sides. Since I'm doing the same operation to both sides of the equation, my equation is still balanced. It's still the same thing. I'm just representing it in a different way. So 5 minus 2x. I generally like to write the coefficient in front of the constant, so I'm going to move the variable in the front, negative 2x plus 5. So what I've done now is I've taken the original equation and I have modified it so I have an isolated variable. In this case, my isolated variable is y. I could have done it for x's too. Y is just easier in this case. All right, next slide, next step. Replace the variable in the second equation with the expression that you solve for in step 1. Solve for the variable in your new equation. So basically what it's saying is I have this new equation where I have the isolated y, and now I can take, let me switch my color here. Now I can take the expression that is equal to y, so in this case negative 2x plus 5, and I can go ahead and plug that expression into the second equation for my y. The reason I want to do that is now I have an equation that only has one variable. The reason I can do that is because of what this little sign right here means. I know that y is the same as negative 2x plus 5. Therefore, I can replace y with negative 2x plus 5. So for this step, what I'm going to do is I'm going to write down my 4x plus 3. Now, instead of putting y in there, in parentheses, I'm going to insert the expression that is equivalent to y. Okay, so the negative 2x plus 5 replaces the y. Now that equals 9. Okay, now I have a multiple step equation, pretty straightforward. I'm feeling a little rusty with the pen because I haven't used it all weekend, so bear with me here. 4x, 3 times negative 2x would be negative 6x. 3 times positive 5 would be positive 15. Still equals 9. Combine like terms, 4x minus 6x is going to be 2x plus 15 equals 9. And subtract 15th on both sides. This goes away. I have negative 2x equals negative 6. Divide by negative 2. I think my first variable x has a value of 3. Okay, so I have my first variable solved. Now I just need to solve for my second variable and check my work. All right, so let's move on to the next step. You notice on this step I went back to my original equations. I'm going to write here as a little reference, x equals 3. We got that in the last slide. Now I can take either one of these equations, doesn't matter which one. I'm going to go ahead and use y plus 2x equals 5. The reason I'm using y plus 2x equals 5 is just in case, let me go back to the slide. If I made a mistake here, solving for y, if I made a mistake and I'm checking it with the equation that's wrong, I'm not going to find my mistake until the last step. So I want to see if I can figure that out right now. So I'm going to go ahead and plug in x, 3 for x now for the first equation, so it'll be y plus 2 times 3 equals 5. So now I'm using the value of x, of 3, to now find what the value of y is. So now once again, I only have one variable that I have to play with. Okay, 2 times 3 is 6, subtract 6 on both sides. Now I have y equals -1. So I have my y now, and I also have my x. So I actually know the ordered pair where these two cross. I'm going to go ahead and write that down. I believe that these two equations cross at 3, -1. All right, not my best handwriting there, but you guys get the idea. So that's where on a coordinate plane I'd expect these two lines, y plus 2x equals 5 and 4x plus 3y equals 9, to cross. All right, and the last step is pretty straightforward. All I'm going to do is check it. So I'm going to verify that the ordered pair is a solution by substituting x and y values into both equations in the system, or by graphing the system to confirm that the point at intersection matches your solution. In short, I'm going to plug in my point. My point is 3. Oh, my pen went crazy on me. Let me go back. Hopefully it doesn't go crazy again. Is 3, -1. Okay, so I'm going to plug that into both equations. I'll do the first one in red. So for y, I'm putting in -1. For x, I'm putting in 3. So you'll notice that the y is now there, the x is now there, -1 is just -1, 2 times 3 is 6. -1 plus 6 is 5. 5 equals 5. Okay, so I verified that solution for my first equation. Now let me do the second one. I'll do that one in blue. Okay, so we're going to do the same thing over here. So I'm going to go 4. I'm going to replace the x with 3 because we think that's the value, the x value where the lines intercept. Plus 3 times -1 equals 9. Okay, there that is, question mark. The reason I'm putting a question mark there is I'm verifying if it's true. We're not solving for something. So 4 times 3 is 12. 3 times -1 is -3. So instead of saying plus negative term, I'm just going to say -3. And then 9 minus 3 is 9. 9 equals 9. Therefore, I know that this is the correct answer to my system. All right, that is how you can solve a system via substitution. Your problem of the week, substitution is probably the best technique to use. If you want to try another technique, that's fine. This is the one I would recommend. All right, have a good week. If you guys need any help, please check in with your math teacher.